Hey everyone, welcome back. In the previous video, we discussed about some kind of consistency. In this video, we are discuss about CAP versus backlog theorem in distributed system. So first, I will set the context of the video, then I will move forward. So suppose these are the servers. Okay, let I switch to N. So suppose these are the servers we have, server 1, server 2, and how they are communicate over each other. They are communicated through networks. Okay, the network calls, which is network protocol, which is HTTP slash. These are the protocol actually, but they are communicate over the networks. Okay, which is internet, you can say. So suppose what something happened between these two server and they are not able to communicate between each other. So these condition is called network partition, in which in which two servers are not able to communicate with each other properly, is called network partition. So suppose in this case we have now 1 2 3 4 5. We have five server. How much? We have total 5 servers which are communicating between each other. Okay, now if you see we have one server, and from here we do not have any connection, so it's crossed. We have another server, we have another server. So here is a triangle, and here they are able to communicate, and here we got a circle of 3. So we have only 3 server that is communicating, and here we have a new set of server which is another server set which are communicating, but they are different. So we have now 2 servers which are different. They are different from here. So here we have a complete distributed system of 5 server, but here we have 2 distributed systems now. One is of 3 server and one is of 2 server. Why? Because the network partition arrives. Why? Because network partition arrive, these server being disconnected, these servers being disconnected to each other. So these are the condition of the partition, which is termed as a network partition. Network partition. And condition like network partition is quite common. You never judge, you never know when these condition will come. Okay, so let's understand the concept of CAP theorem and how we can like hey, so let's understand the concept of CAP, the CAP theorem. So what is suggested by CAP theorem? CAP stand for 3 things. C means consistency, A for availability, and P for partition tolerance. Okay. So in this case, CAP theorem said that in the condition of partition tolerance, in which server 1 and server 2 is not connected to internet properly, and there is some kind of network glitch in between of them, then we have to choose either consistency or either availability, either consistency or either availability. We cannot completely avoid partition tolerance because networks is unreliable. You have to know this thing. Network is unreliable. We cannot trust on network. Okay, so either we have to go to with consistency or go with availability. Now let's move forward and I will explain you each thing. Okay, so suppose we have a database. Okay, which is here is db1. Now we have another database which is db2. Now we have another database which is db db. I have to refresh this, which is db3. Okay, now what happened? Now suppose what happened, it's just an example. Okay, now what happened, Something happened between DB2 and DB3. Something happened between DB2 and DB3, and they are not able to contact or connect with each other. There is some kind of network calls error or something. So now DB3 is unreachable. DB3 is unreachable. Now we have only DB1 and DB2 that is in connection and in place with each other. So now when any client update the data on DB, suppose it's go to DB3, it's update to DB3 or server 3 and says okay update 300 rupees, then DB1 and DB2 stale only 200 rupees because it's available, because it's available. So data should not be consistent. So data is not be consistent. So we have to take it down. So if the server is taking down, if the server is completely down and the load balancer suggests that, okay, this server is take down, just update the data over this DB and it replicate the data also this DB. So it's consistent. So this is CP and CA. Okay, sorry, CP and AP. Now, now Now, this is kind of just a kind of an example in which we think about it. Okay, let's think about consistency in the terms of consistency. Like leader node is down, and in that term, we are doing this thing, and we have multiple option like nodes. Like we have a like a election happened, okay, and he found a good leader node, and then this is happening. Then this is the situation. Okay, I will explain you in more detail. This is just an example to show you how is the consistency uh, partition tolerant work in this CAP theorem. Means just be little conscious here. CAP, CAP, consistency, availability, partition tolerance. Okay, got it. Now just be conscious here. CAP. Okay. Take a pause. We have multiple servers. Okay, the S3 take down, or suppose the leader node S1 take down. We have other server as well. We have other servers as well. When the load balancer check, okay, S1 is down because first request from user go to load balancer, then the load balancer we got option to write to all. So server is down. He checks, okay, who is up right now? All these all are ups. Okay, now who is the leader node here? Election happened, and suppose S2 become leader. So now request go to S2 and S2, S4, S5, S3 are the followers node and they update the data according to S2. So we have a new leader node. But, but, but what will happen if suppose a situation where the leader election happen, but it suppose if have to only two node and the leader election happens, and because it need majority to win and there is no leader node, and the particular system does not able to find a leader node, now system will down. Now system will down and it suggests we cannot give you a right operation. We cannot able to give you the right operation because S2 can store the data or S3 can store the data. S2 can store the data or S3 can store the data. So it might be lead to inconsistency. So here, so here we avoid it. Here we avoid it. So this is CP. Consistent partition tolerance means we give a majority to consistency, means like replicating database as compared to availability. Okay, no issues if there is if it's a possibility of, okay, the data must not be consistent, we just make our server down. We just like in banks, bank server down is fine if rather than pushing a wrong money in a wrong account. Because then the transition and then the transaction, if the even the server is up, is very 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 difficult to do. Another case is AP, which is availability partition tolerance, in which it is the same, but the difference is we prioritize availability more than consistency. Like in the case of, suppose we do not have an write app operation, we have multiple servers to streaming services and it stream directly, and suppose even one server is down, we can just put the other server to do the same task and they are available and up and streaming properly. So it's an example of availability partition tolerance. So in a CAP theorem, we have three themes: consistency, availability, and partition tolerance. We cannot tolerate this, we cannot remove this. So let I made the triangle again so you can better understand. P A C. C and A at the bottom is not possible, so we either we can go CP or PA according to this theorem. Okay, means you can dig deeper into this, but it is like in the worst case scenario, it's not possible. When the system got down, at that moment you can just avail consistency and availability both at the same moment. You have to just uh, lose one to gain other. Now let's move to Paclak theorem. It is just an up part, you can say, just an increased segment of the CAP theorem, in which suppose you have a partition occur. Okay, you have a partition occur. Okay, and you do not have any partition occur, so you have to choose between availability and consistency, which I explained you. Okay, now if there is no partition occur, then you have to choose between latency and consistency. So what is latency and consistency means? Suppose you have a server S1 and you have multiple servers. So suppose you one request came to it, it have to in a distributed system, every server must have to contain the same data, you can say DB. Okay, mean same DB. So when you have to update all the data, it takes some time to do it. And at the same moment, if like 1 billions of users are doing the same thing, it like a lot of time to do it. So it create a network latency. And also network is, as I told you earlier, network is like unreliable asset, so you cannot trust them. So why here is the concept of latency and consistency? Like if in between, suppose we have db1 and db2 and db3 and db4, what will happen? Suppose that due to the network latency, the data between in db1 to db3 is not correctly propagated. The data between db1 and db3 is not correctly propagated. So what will happen? We lost the consistency. If any user asks data from db3, what will happen? It got a wrong data, because due to latency timeout, it stored the wrong data. So that's why if there is a no partition itself, we have to choose between the latency and consistency. If you choose latency, then your system is faster, but you may got some kind of inconsistent behavior between your database. But if you choose consistency, you can say like a little lag or little slowness in your servers. So these are the example of Paclak theorem. It's just an up version of the CAP theorem. Okay. So thanks for watching. Keep subscribing and keep watching. Bye bye.